Have any of you ever heard of the law of sines? No? Okay. Um, you guys took geometry once upon a time, right? I think the Huntington kids did and the Farron kids did not. You skipped right over it. Good. Ninth grade. Anyway, so half of you, this will be new material, and half of it won't be new. Um, if you exclude your geometry class, everything you learned in high school involving trigonometry dealt with right triangles. So what we said was take any right triangle, and the sine of any angle, excluding the right angle, had all these properties. Opposite over hypotenuse, we drew a graph, we made a unit circle, we did all sorts of things. And everything we did applied to right triangle, where theta was either here or there. We did figure out how to extend theta beyond 90 degrees, but it was just a fancy way of drawing a new right triangle. So remember when we had rotations and we reflected over here, and that might be 135 degrees, that angle, and we said draw the right triangle so that theta is less than 90. Okay? No, that's all from last year. Okay, and we did a little bit of review this year. Today, we're going to talk about non-right triangles. Okay, so you can still perform calculations on non-right triangles. In the past, if I told you an angle, 30 degrees, and I told you a side was 8, that's enough information to calculate everything else. Or, instead of an angle, if I told you 2 sides, that was also enough to calculate everything else. So if you either had an angle and a side, or 2 sides, and you knew it was a right triangle, we could use trig to solve the whole triangle. Well, what if it's not right? If it's not a right triangle, then the rules kind of disappear until today. Okay? So, and the people who wrote this will excite you. You'll be so thrilled. So you look at the top. Right triangle trigonometry can be used to solve problems involving right triangles. However, many interesting problems involve non-right triangles. And many non-interesting problems also involve non-right triangles. In this lesson, you will use right triangle trigonometry to develop what's called the law of sines. Now, there is a law of sines and a law of cosines. Law of sines is easier, and it always works. The law of cosines is kind of more complicated, and sometimes it works, and sometimes it works twice. So stay tuned for that. So consider oblique triangle ABC. Oblique is just a fancy word to mean it doesn't have any angles that are equal, and it's not right. So sketch an altitude from vertex B. So I'm going to zoom out. So an altitude, remind me what an altitude does. It goes through the vertex, and it's perpendicular to the opposite side. So we'd have to draw a line down so that we have a right angle. Okay, we'll label that altitude as length k. Now that has split triangle ABC into 2 right triangles. Everybody agree? Okay, and k is the same value on both triangles. It's a leg of both of those 2 triangles. So the altitude creates 2 right triangles. Notice that angle A is contained in one of the right triangles. So A is part of the bigger triangle, and C is contained in the other. Using right triangle trigonometry, write 2 equations, one involving sine of A and one involving sine of C. So sine of A in that further left triangle is what ratio? K over little c. K divided by little c. All right? What is the sine of C? So let me, if you don't quite understand what we're doing, so in this triangle here, sine of theta is opposite over hypotenuse. So K is the opposite and C is the hypotenuse. Now if I switch triangles, and I look at this triangle, and I'm still doing sine of C, K is the opposite and A is the hypotenuse. So K over A. Notice that in each of these equations, notice that then each of the equations in question 3 involves K. Why does that happen? Because they both use the same altitude. So let's solve each equation for K. How would I change this so that it said K equals? So K equals C sine of A. And in the other one it's going to be K equals, I want to solve for K, so I times by A sine of C. I haven't lost anybody yet, have I? Everybody okay? You lost? So, do you understand these ratios? Okay, so all we're doing is getting K by itself. So C is divided, so we multiply it. And A is divided, so we multiply it, and I get K equals C sine of A, and K equals A sine of C. Okay, I'm going to get rid of most of this. Oops. Didn't mean to get rid of that. Oh, shoot. Sorry. Okay. So now let's go down. Since both equations in question 4 are equal to K, they can be set equal to each other. So if K equals this stuff and K equals this stuff, then C sine of A is equal to A sine of C. Notice that the equations in question 5 no longer involve K. So we've eliminated the need for the altitude. So if I were to draw that original triangle again, and this was so this is C and this is A, that's B, so little c, little b, and little a. So what this is saying is, if we take little c and we multiply it by the sine of A, that's exactly the same thing as taking little a and multiplying it by the sine of C. Right? Well, let's get all of our a's on one side of the equation and all of the c's on the other side. So how could I move this a to the other side? Divide. How could I move this c to the other side? Divide. So I get the sine of A over A is equal to the sine of C over C, which, if we did this whole process again, if I were to start with the triangle and instead of drawing the altitude through capital B, if I drew the altitude through here, then I would find out that sine of C over little c is exactly the same thing as sine of capital B over little b. And actually, all three of those ratios are the same. So if you take an angle, you take the sine of that angle and divide it by the opposite length, that's equal to the sine of any other angle divided by the corresponding opposite length. Okay? And sometimes it's shown differently. Sometimes it's written like this, A over sine of A equals b over sine of b, which equals c over sine of c. And it doesn't matter how you do it. If you prefer one way or the other, that's fine. It doesn't really matter. It's the same ratio. It's like saying 2 over 3 equals 4 over 6. That's true, right? If I flip it upside down, is 3 over 2 equal to 6 over 4? Still true. So it doesn't matter which version of the equation you use. But now, if we know 3 parts of a particular triangle, then I can find all of the other parts. Well, depending on if they give us the right piece of information. So let's forget this sine of b idea. Let me get rid of some of these. Okay. So let's say the angle C is 20 degrees and angle A is 95 degrees. What would I need to know in order to fill out the rest of the triangle? Either little c or little a. Do I need both? No. So if I told you that little c was 10, then I can solve for... So if you look at your formula, I have this, use a different color, I have this, and I have this, and I have that, so I can solve for little a. So all I have to do is fill it all in. So the sine of 95 over a is my unknown. That's equal to what? The sine of 20 over 10. How do I solve for a? Cross multiply. So cross multiply, and I get a sine of 20 equals 10 sine of 95. Divide by the sine of 20. So all I do is calculate that out. 10 sine of 95 divided by the sine of 20. What does that tell me? That's the length of A. So A is now 29.126. Okay. So let me get rid of this. Can I find the other two measures? How? Right, B is easy to find. 95 plus 20 is 125. Wait, 115. So 180 minus 115 is 65. And then I can change my formula, get rid of the C's and put in B's. So which of these do I not know? Little b. That's the one I'm looking for. I have everything else. So I just plug everything into the formula. So the sine of 95 over 29.126 equals sine of b, which is 65, over b. Cross multiply. So that gives me b sine of 95 equals 29.126 sine of 65. How do I solve that? Divide by the sine of 95. So I'm going to do the answer times sine of 65 divided by the sine of 95. And little b is 26.5. Now I want to point something out that I pointed out before. You can always look at these triangles and figure out if you screwed it up or not. Okay? The biggest angle, 95, should be opposite the biggest side. The smallest angle should be opposite the smallest side, and the middle angle should be opposite the middle side. That will always be the case. If two sides are equal, then the two opposite angles are also equal. If the three angles are all the same size, then all three sides will be the same size. So in every triangle, that relationship is true. Okay, page over. Okay. So this wants you to go back through, and instead of using A and C, it wants you to use A and B. I'm going to leave that one up for you to do. So, go ahead, work on that.
Now that we have the new worksheet, we'll do the problem system number one. And I want to point out, if you look at all of these triangles, the relationship between the sides of angles is either, in this case, it's angle, side, angle. And number two, it's angle, angle, side. Number three, it's angle, side, angle. Number four, angle, side, side, angle. As long as you have either angle, angle, side, or angle, side, angle, which means you have two angles, then you can use the law of sines without any problems. Yes. That's the trouble. If you have, sometimes it works. We know triangle, sometimes so this whole front page is either angle, side, angle, or angle, angle, side. The back page, tomorrow I'll teach you how to deal with angle, side, side. Because at times it doesn't work at all. Let's look at number one. The sine of A, which is 118, over, it wants us to, wait, it wants us to find this length here, which is little b, right? Well, it's going to take some time to find little b because we're going to have to find little a first. We don't have enough, we don't have angle, what did I do? Oh, well, that'll make it easy, yeah. So, what is angle C? 40. That'll do. So now I'm going to do sine of C over C equals sine of B over B. And we don't have enough information for it to work. So the sine of 40 over 24 is equal to the sine of 22 over B plus multiply 24 sine of 22 divided by, so I get B sine of 40, so I just divide by the sine of 40. So 24 sine of 22 divided by the sine of 40. So 13, 14 is good. Okay, those are pretty easy. Do you want to see another one or try it again with time? Try it again with time. Understood. Okay, good luck.